Assalamualaikum warahmatullahi wabarakatuh. My name is FARHANAH binti BAKAR. Number matrix AA191797. I will present the introduction about our report. The aim of this study is focused on understanding of swelling and shrinkage phenomenon of soils, and objective of this study are to find the problem that caused by swelling and shrinkage of soils and to determine the solution for the problem.
Assalamualaikum, my name is Haziqah binti Muhamad. My matric number is AA190803. So I will present about definition. So what is swelling and shrinkage of soil? Swelling and shrinkage is the change in the volume caused by change in humidity of clay soil. So this is among the factors that influence the amount of soil can swell and shrink by determining the change in moisture content. So the change in moisture content is depend by volume change that occur as a result of change in moisture content of clay soil. Second, swell and shrink can be determined through the quantity of expanding clay in the soil. Clay soil and fine grain can absorb amount of water after rain, is causing the soil to become moist, and when dry, soil can become harder and causing shrinkage and crack to the ground of the soil. Then, the density of the soil also can influence the soil swell and shrink. This is because when the soil becomes moist, it indirectly increases the density of soil. The amount of structural loading also influence the amount of soil can swell and shrink. And the last one is the clay type in soil. So the clay type in soil depend on the fine of soil, because fine grained soil is more absorb the water. So when absorb more water, when it's dry, it will become harder and causing shrinkage. This process, hardening and softening, is contribute to shrink swell behavior.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad HAIQAL bin SYARUNNIZAM, matric number AA190109. And as for today, I will talk about one of many problems that is related to geotechnical engineering. For this presentation, I will talk about expensive soil. Okay, actually, expensive soil means that this kind of soil have the ability to shrink and swell. Or in other words, expensive soil means that this soil have the ability to change in volume due to the changes of moisture content. And there are two methods of identification to classify whether this soil is expensive soil or not, which is differential testing method, and secondly is mineralogical identification method. Before we conduct any sort of proper identification method, there are several symptoms that we can see with our bare eyes that indicates that the soil is expensive soil. As we can see here, there are several defects that we can see with our bare eyes to the structure and the road. Let us take a look at this house. We can see there are several broken windows and doors, and we can also see some crack at the structure. So these are several symptoms that indicates that the soil is expensive soil. And that is all from me. Thank you.
Hello, my name is Muhamad bin JUAINI, AA190219. Next, I will continue the presentation about the problem of swelling and shrinking of soil. Next is subsidence. Subsidence can be defined as sinking of the ground because of underground material movement. It is most often caused by the removal of water, oil, natural gas, or mineral resources out of the ground by pumping or mining activities and dissolution of limestone. Subsidence can also be caused by particle realignment caused by water infiltrating a fine grain type of soil known as loss or compression of compressible soils like peat. Subsidence can cause buildings get weakened and collapse. Railway lines and roadways become twisted and destroyed, and underground sewer, power and water lines are severed. Subsidence is an extremely expensive sort of mass wasting that also represents a risk to human life because of its propensity to ruin property on a vast scale. Next, the solution for swelling and shrinking of soil is stabilized soil. Soil stabilization is a physical, chemical, mechanical, biological or combination method of modifying a natural soil to fulfill an engineering objective for construction process. In order to strengthen road pavement, improvement include boosting the weight-bearing capacities, the size strength and overall performance of in-situ subsoil, sand and waste materials. By reducing permeability and improving overall strength, the stabilization process ensures that the soil is stable. As a result, the soil becomes more stable and capable of carrying more weight. To ensure the best construction and longevity, the most recent project of roadway requires a firm foundation. The foundation must be supported by a solid soil that can appropriately transfer the building's total load. If the soil is poor, it will consolidate and swell within the time. There are many materials for soil stabilization. For example, lime, cement, bitumen, chemical compounds, and geotextile. And there are many methods for soil stabilization, which is mixing materials, chloride stabilization, and electrical stabilization. Mixing materials is by far the most popular approach for soil stabilization. It is because it can precisely identify the type of soil being dealt with in order to apply the appropriate substance. Mixing materials also is cheaper than the other method. Chloride stabilization is a common way for soil stabilization too, but it has a risk, which is it can risk the environment of plants and wildlife. And lastly is electrical stabilization. Electrical stabilization is costly, so it isn't used very often.
Another method to overcome the problem is using structural design approach. During the planning, the structural foundation should be built to prevent unacceptably high levels of foundation and structural disturbance. Then, if possible, foundation loading pressures should surpass soil swell pressures but should be less than the bearing capacity to keep foundation displacements below acceptable limits. To determine safe or permitted operating loads commensurate with tolerated settlements, factors of safety are used to the ultimate bearing capacity. While for the foundation system, it should be designed so that the superstructure receives no more than the maximum tolerable distortion. In low swelling soil situation where the expected footing, angular deflection or span length ratios are on the order of 1/600 to 1/1000 or 0.5 inch or less of movement, shallow individual or long continuous footings are frequently employed. For the slab, stiffened mat foundations can be used in swollen soil locations where the expected differential movement might be as high as 4 inches. For deep foundation, shaft deflection or spacing ratios of less than 1/600 should be achieved using this foundation. The superstructure should deform in accordance with the base to allow the building continue to perform its tasks while also contributing aesthetically to the environment and requiring minimal maintenance. The brittleness of the building materials, length to height ratio, relative stiffness of the structure in shear and bending, and mode or deformation all affect a structure's capacity to sustain deformation. That's all from me. Thank you.
So, for the conclusion in this study, geotechnical engineering is interconnected each other with structural engineering because strength of building structure also depend on soil condition. The study geological material on both sides has played a crucial role in designing and building stable structure from do not settle, defective, collapse, or when the foundation failure. So, as the site engineer, play an important role in finding solution in overcoming the soil problem that occur during construction and to make sure that soil condition is in good before run the construction. This is because in order to ensure that the building is safer after construction, as well as reduce the cost of loss and protect human life from any danger or accident happens.